friends, how are you? I hope now you must be feeling relaxed and confident while writing C++ programs. But have you tried your hands on some large complex programs? What have you said? IT is unmanageable. Oh dear, just divide the programs into small pieces called functions. In order to make large programs more manageable, programmer divides the program into small pieces called functions. In other words, we can say that function makes large computing tasks into smaller ones. Thus, a function is a single comprehensive unit that performs a specified task. This specific task is repeated each time the function is called, invoked. They work together to accomplish the goal of the whole program. It is just like decentralization of work. The work is distributed to subprograms and results are taken back from them. Main advantage of using functions is that it increases the modularity of program and reduces code redundancy, thereby saves development time, effort and cost. Thus, a function contains set of statements which can be invoked from any part of the program. Now let's understand how the flow of control is transferred between main program and function. Let the main program calls a fun1 which is written separately. When a function is called, the control is transferred to first statement in the called function and the function starts execution. When a function encounters a return statement during execution, control is again transferred back to the statement followed to the called function, program and execution continues with rest of the statements in calling program. Necessary components for using a function. In order to use functions, it is necessary to have following components in your program. First, a program which uses the function. A program may consist of single or multiple functions. Second, function declaration. Function may or may not be declared before use. Third, function definition. But as variables cannot be used without declaring them, similarly a function has to be defined before use. Fourth, call to function. A program can call or invoke any number of functions for any number of times. Since there are two methods of using a function, that is with declaration or without declaration, let's discuss them in some more detail with example. First method is when we declare a function before it is called. Such type of declaration helps the compiler to have knowledge about the functions that are going to be used in a program. Let's write a program to calculate square of a number. You can see here that function is declared before definition. You can see here that after accepting a value of x, square of number is calculated and stored in y. Now let's see that the main program CLR SCR function is used to clear the screen. SQR is a function call for calculating the square of a number inputted in a function. Second, by defining it before it is called or invoked. Here, function is not declared beforehand. It is simple for smaller programs, but for larger programs, it becomes unmanageable as each calling function has to be defined before being used. Here, I am defining the function and then using it in main program. You can see here that after accepting a value of x, square of a number is calculated and stored in y. Now let's see the main program. CLR SCR function is used to clear the screen. SQR is a function call for calculating the square of a number inputted in a function. Can you notice here that function is defined before use but it is not at all declared. Now let's see how flow of control will be transferred. In both the cases, as soon as function is called in a main program, control of program is transferred to the function SQR and all these statements are executed sequentially. Control is transferred back to main program, return Y is encountered. Function definition. Now let's learn how to define a function. A function definition is a complete function in itself and is defined by a function name, that is header or declarator, followed by a pair of braces in which one or more statements can exist, that is function body. It is not followed by a semicolon. We can notice here that function definition has 5 parts. First, function type. Second, function name. Third, arguments list. Fourth, function body. And fifth, return statement. Now let's explore each part. The first part is function type. Function type defines the type of value which will be returned after its execution. Type can be int, float or char, etc. If type is not specified, then compiler returns an integer value. The second part is function name. Function name specifies the name which can be called by the main program. Function name can be any name but follow the same syntax rule for defining variable. A function is invoked on appearance of function name. Next we have to give arguments list. The argument list contains the number and type of arguments. The variables defined in the argument list are called formal arguments. These arguments are declared in the bracket after function name. There are 2 methods of declaring formal arguments. First, in this method, arguments are declared within the function but their type is declared separately. Or in the method shown on the screen, here arguments are declared along with their type within the function. Arguments can be global constant, global variable or a function call. Let's take another example. In this example, argument x is variable while argument y and z are initialized. Such type of declaration is helpful when a function is called with default argument. Now let's take another example. In this case, out is int type of argument and it will have value from display function. Such type of declaration can be used when arguments are passed by a value only. The fourth part of the function is most important and it performs the actual work. This part is function body. Body of a function is enclosed in curly braces. It contains the set of statements which is being executed when the function is called. The variables which are declared in the function other than formal arguments are called local variable of function. This function body may call another function which is predefined. If function calls another function, then it is called as nested functions. Next part, again very important, it is return statement. Do you know what is return statement? Return statement returns the value from the function to the calling program. When return statement is executed, it immediately transfers the control to calling program. Any number of return statements can be present in the function, but each return statement can return only one value. The returned value is same as type declaration of a function. The return statement may or may not contain any expression, just like return or return in brackets expression semicolon. Function declaration or function prototype. Now it's time to see how a function is declared, or in other words, what is prototype of a function. Function prototype is the declaration that defines type of argument passed to the function and the type of value returned. The function prototype is a declaration statement before defining a function. It acts like a template. When a function is called, the compiler uses the template to ensure that proper arguments are passed and the return value is treated correctly. Any violation in matching the arguments or the return type will be caught by the compiler at the time of compilation itself. It is known as strong type checking. A semicolon terminates it as it is a complete statement in itself. The syntax is as shown. Example 1. Int mat in brackets int a, int b, int c semicolon. Example 2. Int mat bracket start a comma b comma c bracket close semicolon. Each argument variable can be declared inside the function independently without data type. Example 3. Display or display void. Here function contains no argument. Example 4. Void display. If a function have open parameter list, then use the ellipses in the prototype. Calling a function. Now you have learned how to declare or define a function, but the function has to be connected to the main program. In other words, we can say that main function must call a function. A function is called, invoked on appearance of function name with or without arguments in a calling program. A function can be called for any number of times depending upon the requirement. The syntax is as shown. Execution of call statement will transfer the flow of control to the first statement of the function, and subsequent statements will be executed till return statement is encountered. Since function can return a single value only, it can be assigned to a variable also, like variable name is equal to function name bracket start bracket close semicolon. Example, this figure can illustrate this. Please note that P is a variable in the main program that calls a function sum. The flow of control is transferred back to the main program as soon as return statement is encountered. Passing arguments to function. The communication between main program and a function starts with the passing of arguments to the function. Depending upon the number and type of arguments passed to a function operates in different manner. This property is also called as polymorphism. This can be viewed like players playing a game. Which game they will play? Obviously, if they have football, they will play football. If they have hockey or cricket, they will play it. So we can symbolize game as a function and football, hockey or cricket kit as arguments. Depending on these type, game will be selected and each of them will have different playing rules. That is, the body of each function will be different. Technically, the passed arguments are either actual or default. Actual arguments. Actual arguments are variables that are defined in the main program. Mostly, we use different variable name in called and calling function, but we can use the same variable. Any number of arguments can be passed to called function, but its type, order and number of actual and formal argument must be same. Default arguments. Default means without specification. C++ allows us to call a function without specifying all its arguments. In such cases, the function assigns a default value to the parameters that does not have a matching arguments in the function call. Default values are specified when the function is declared. The compiler looks at the prototype to see how many arguments a function uses and alerts the program for their possible default values. The prototype shown declares a default value of 20 to the argument b. A subsequent function call to this function will be value is equal to sum in brackets 10 semicolon. Here you can see that only value of a is passed since b has a default value as 20. One point is clear from this, that is, only the trailing arguments can have default values, so we must add default values from right to left. Now, the next point that you all must be clear about is where and when to use default function. Default arguments are given only in the function prototype and not in the function definition. Default arguments are used in two situations where programmer wants to use expandable function, that is, programmer wants to add new arguments without losing older values. This is mostly used in function overloading. Second, arguments have same values every time parameters are passed. Now the question arises, how to call a function? Depending on the type of arguments passed, a function can be called following in three ways: call by value, call by reference, call by constant reference. Call by value. In call by value, a copy of the variable is made and passed to the function as argument. It initializes these parameters to the value passed. They are then accessed like any other variable in the function body. Here the function cannot access original argument but only their copy. Thus, it provides security to the original argument. With this method, changes made to the parameters of the function have no effect on the variable in the calling function because the changes are made only to the copies. That is, changing in the formal statements have no effect in the actual parameters value. Here, arguments are in read-only mode. This program swaps the value of a and b. This is a main program which calls swap function. This is the body of the swap function. The output is a is equal to 10 and b is equal to 20. The values of the variable are not exchanged. You can just notice how arguments are communicated. If the sample input is a is equal to 10 and b is equal to 20, then inside the function value of a and b after swapping is 20 and 10 respectively, while after returning from the function value of a and b are again 10 and 20 respectively. The reason for this is that is the swapping of arguments are done within the function only and it does not affect the values of a and b in main program. The second method is call by reference. On the other hand, call by reference is a method in which the memory address of each argument is passed to the function. By this method, the changes made to the arguments of the function will affect the variables in the calling functions. That is, changing in the formal argument values have direct effects in the actual arguments value because we are passed the address of variables as actual parameters to the function. Here, arguments are in read-write mode. The other advantage of using it is that it facilitates C++ functions to return more than one value to calling program. The same program of swapping of variables can illustrate this. Here, the arguments are passed as reference. You can see here that swapping is done with the actual addresses of the variables, that is why the output shows that a is equal to 20 and b is equal to 10 outside the function, that is the values are exchanged. The third method of calling a function is call by constant reference. While passing the arguments as value, lot of storage space is duplicated, especially in case of graphical images. So it is better to use references as passing arguments. But the problem here is that value of actual argument gets changed sometimes. There is third way to pass argument as constant reference. Its working is same as passing argument as reference, but function cannot change its actual value during the program run. Thus, arguments passed are read only. It is mostly used when array object arguments are passed. This can be explained by an example in which arguments are passed as value or reference and constant reference. The example is as shown. This is a function PCF in which argument I is passed as value, argument j is passed as reference, while argument k is passed as constant reference. This is a main program. If the sample input is x is equal to 3, y is equal to 4, z is equal to 5, here the value of z is not changed as z is passed for a constant reference. Now I think it is quite clear about the basics of function. Next time we will discuss more about functions. Thank you.